In today's video, we're going to explore parallel circuits, and in particular we'll consider how they deal with potential difference, current, and resistance. Parallel circuits are those that contain more than one loop, and in most cases, each loop will contain just a single component. This design makes parallel circuits much more useful and practical compared to series circuits, because when each component has its own dedicated loop, a failure in one component doesn't affect the rest of the circuit. For example, if one of the lights in your house blows out, all the other lights will still continue working normally. In real-world applications, though, circuits are often a combination of both series and parallel sections, meaning while we might have several loops running in parallel, some of those loops might still contain more than one component. If you're unfamiliar with how series circuits work, it might be helpful to check out our earlier video on that topic. We've added the link in the description below. Now, the first key thing to understand about true parallel circuits, meaning those where each loop has just one component, is that every component receives the full source potential difference. So, if we're using a 12-volt battery, then every single component in each loop will have 12 volts across it. Next, let's talk about current. In a parallel circuit, the total current is shared between all the loops. For instance, if we have a total current of 4 amps flowing through a 2-loop circuit, it could be split unevenly, like 3 amps in the first loop and 1 in the second, or evenly, with 2 amps in each loop. Regardless of how it's split, if we add the current in all the loops together, the sum will always equal the total current supplied by the battery. In this case, 4 amps. The way the current divides depends on the resistance in each loop, with higher resistance paths taking in a smaller share of the current. You can picture this like water flowing down a hill. If the water has 2 or more possible paths, most of it will naturally flow through the route with the least resistance, and only a small amount will go through the tougher path. That's exactly how current behaves in a parallel circuit. Lower resistance loops get more current. Now, let's talk about one unusual property of parallel circuits. It might seem counterintuitive at first, but adding more components in parallel actually reduces the total resistance of the entire circuit. It's one of those physics facts that's strange but true. A helpful way to understand this is to go back to the water analogy. Imagine we open up another route for the water to travel, even if that new path is narrow or partially blocked. The very presence of an extra route still gives the water more options, which means it can now move down the hill more easily. An easier water flow means less overall resistance. So in physics terms, the more loops we add in parallel, the lower the total resistance becomes, even if those loops have big resistors in them. That's why parallel circuits are not just useful but also very efficient in many electrical systems. Anyway, that's everything for today's video. So if you found it helpful, make sure to give us a like and subscribe to the channel, and hopefully, we'll see you in the next one.